Hello, 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 everybody, and welcome to Science. Today, we're starting a new unit, a new scientific venture. Oh my gosh, amazing. Are you ready? Are you ready? We are going to start Intro to Mixtures today. This physical science unit is going to be all about mixtures and solutions. Solutions is going to be kind of a tricky word because we're going to end up using it two different ways. There's one way that's solution as in the answer to a problem, right? Finding a solution. And then there's going to be also a more of a scientific solution. What is a solution? Solution is a noun versus a thing. Well, I guess they're both nouns, but solution as a thing you can hold in your hand rather than a thing that you answer to a problem. That was probably more confusing than it was helpful. We won't worry about solutions today. We're going to worry about mixtures today. What you're going to need, your science notebook, a pencil or a pen. If your science notebook is on paper, I know some of you are still being really successful with your Google Docs science notebooks, which I think is great. We are going to be making some observations today, and we're also going to be designing a way to separate a mixture back into its parts. So let's start to talk about some of the vocabulary that we're going to be using in this unit. This idea of mixture I've been talking about already a lot. And over here, right there, there it is. Right there, a mixture in its most general of terms can be defined as two or more materials mixed together. I think a great example of a mixture, I had a bowl of cereal for breakfast this morning. What were the different parts in a bowl of cereal, which is a mixture? It is two or more materials mixed together. Let's think about what are the parts in a bowl of cereal. You've got your cereal, you've got your milk, right? Those are the two biggest ones. You know, assuming most of us use milk. Maybe it's oat milk, maybe it's almond milk, maybe it's soy milk, maybe it's orange juice. It's probably not orange juice. That doesn't seem right. But all those kinds of milks all work. And sometimes, if you've got a cereal, let's say one of my favorite cereals is Honey Bunches of Oats. And that in itself is a mixture because it's got a whole lot of different things in it. It's got the little cornflake parts, it's got the little oat cluster parts. Delicious. Right? Trail mix, mixture right in there, right? It's a mixture of, you know, your raisins, your M&Ms, your peanuts, your almonds, your granola, whatever else goes into trail mix, right? Essentially, that's what we're talking about here, okay? And we're going to make some scientific mixtures today using some different materials. We're going to take some observations on what those mixtures look like. And then we want to think about how do we separate the mixtures back out? What are we going to do? We have to design a solution and answer to our problem here. First, let's think about this example from 4th grade of a mixture that we learned. Okay? Soil is a mixture of what? Okay, we talked about this last year in Earth Science when we were talking about soils, rocks, and landforms. Thank you, Ava, for letting me know that I didn't make the copy of the exit ticket thing. Don't worry about that now. Just watch the video. Soil is a mixture of, there's a lot of different components in soil, right? We had our types of rocks broken down by size. You might have gravel. You might have pebbles. You might have sand. You could have silt. You could have clay, right? And you're also going to have organic material, our humus, our dead leaves, our dead animal parts, right? So all of these things together make soil. They are a mixture. Can you separate these things out? Certainly. You just have to find the right tool or the right system that'll help you separate them out, but you certainly could. today we're going to be dealing with 3 different materials, and we're going to be mixing all of them with water. So here's the table that we're going to set up on our, or in our science notebooks. Okay, so at the top, we're going to have 2 kind of columns here, 2 general columns. One is going to be visual observations. Again, this would be a little easier if we're in the classroom, but we're making the best of it. So visual observations. And the second one is going to be weight. We want to know how much this mixture total weighs. Okay, and then we're going to be using 3 different materials, all mixed with water, separately mixed with water, not all mixed in the same thing, but separately mixed with water. Okay, so first thing we're going to have, gravel. Okay, again, a particular size of rock, smaller than pebbles, larger than sand. That's a great example of gravel right there. Looks a little bit bigger than sand, but it's a little bit smaller than a pebble. Okay, so there's our gravel. The second thing, this big long thing over there and also over there, written in 2 different places, is diatomaceous earth. That is a mouthful, but don't have it actually be a mouthful. You don't want to eat it. Diatomaceous earth, and again, it says right there, not for human consumption. Don't eat it. Diatomaceous earth is actually really cool stuff. Essentially what this is shells in a powder. There is a single-celled algae known as a diatom, okay? And these things are pretty weird. They're like not plants, they're not animals, they're like a single-celled thing, and they have shells. Really, really small ones, but still shells. Their kind of shell or their skeleton is made of what is essentially silica or silicon oxide. And silica is a natural compound that's found in everything. Rocks, I think I was reading somewhere that it's like 25% of the Earth's crust is silica. Okay, things like emeralds and quartz are made of silica, and glass is made of silica. Okay, just kind of in a different shape, so it doesn't look like this. It looks like that window over there. And pretty cool stuff. So it is a naturally occurring compound, and it's got a lot of uses, like not in diatomaceous earth form, but silica can be like, it has some like, vitamin, potentially health properties. In this case, what this is most often used for are in things like filters. So like swimming pool filters might have, silica in there, and the water flows through it, and all the diatomaceous earth catches all the particles and stuff, but lets the water flow through because it's small enough, it's big enough, it's got space for water to flow through. Okay, and it's also used, it's a great thing, and is a natural pest deterrent for your garden. Okay, if you have, let's say you've got some vegetables in your garden that slugs and snails like to eat, right? If you just put a ring of diatomaceous earth around your plants, essentially what that is for slugs and snails is that would be like walking through broken glass to get to those plants. And they're going to be like, nope, no thank you. I would rather not cut myself into a bunch of different pieces. So all you have to do is put a little ring of diatomaceous earth around your broccoli plant or your kale, and the slugs and snails can't get to it. And it's a great way, without using a pesticide, to keep all of your plants nice and healthy. Okay, so we're going to make a mixture with this in water. And the last thing we're going to make a mixture of, where is it? Oh no, I'm hooked into the microphone. Whew, thank goodness. Is salt. Classic kosher salt. You might bake with this, you might put it in food. Okay, I've got them here in 3 different little containers. Okay, here's our diatomaceous earth. There it is. Okay, here's our gravel. And here's our salt. And what I'm going to do is I've got a syringe here with 50 milliliters of water. And I'm going to add it to each and then stir it around and mix it up. So let's actually head on down to the table here. Does everybody have the chart written down? If you don't, get it down quick. Okay, you need 3 rows, 1 for gravel, 1 for diatomaceous earth, 1 for salt. If you don't spell diatomaceous correctly the first time, it's fine. It's also written there. And then visual observations, what do you see? And the weight. So here we go. Coming on down. All right, here we go. So we've got our 3 different containers here. We've got our 3 different things here. We're going to start with our gravel. So okay, easy enough. Give it a little stir. And why don't you take some observations of that while I see how close I can get it here. That's actually pretty good. Okay, while I prepare the next one, the diatomaceous earth. So make some observations. What do you notice about the gravel and the water? Okay. How are they interacting? I did stir it around. I can stir it again if you want. Okay. How is it interacting? How is it mixing? Okay, take those observations down. Don't worry about the weight yet. We're going to weigh them in a second. All right, take about 30 more seconds while I stir this diatomaceous earth here. I'm a little heavy on the salt, so I'm going to take some of the salt out. There we go. Don't want too much salt in there. Okay. Da-da-da, do-do-do. All right. Gravel away. Diatomaceous earth. There we go. What does it look like? What do you notice? Okay. While you're doing that, I am preparing the salt and the water. Look at what you notice with that. What do you see? Okay, I'm also going to hold it up just a little bit because I do want you to, let's see if we can see kind of a cross section here. There we go, and then there's the bottom. So I do want you to notice there is a little bit of a layer collecting on the bottom. Okay, it's not all the way, you can see it there when I tilt it, that there's a solid layer kind of on the bottom there. Do you notice that? Okay, good. Swirl that back around there. Okay, see how it's gone now because I swirled it. Okay, if I let it settle, you can see that there are some parts, and it's even kind of collecting on the side there. It's tough to tell. I know this would be a lot easier in the classroom. Alas, here we are. We're making the best of it. Okay, last, saltwater solution. There it is. What does it look like? What do you see? There's the bottom. Yeah, pretty clear, huh? Curious. Where'd the salt go? one that's tricky because we can still see the gravel. We can still see the diatomaceous earth, but we can't see the salt anymore. There's the right cup, right? Yeah, that's the right cup. I don't know any others here, so that's the salt water. Okay, now, the other thing we're going to do is we're going to weigh it because once we separate out our mixtures or attempt to separate out our mixtures, okay, the weight is going to give us some clues as to whether we separated it out all the way or not. All right, so we put in 50 milliliters of water into each, and 1 milliliter of water weighs 1 gram. Okay, so if we get our water back to 50 grams of weight, we will know that we've completely separated our mixture. If it's more than 50 grams, we know that there's some other stuff still in there. So we're going to use our balance to weigh our items here. Okay, here's our balance. And I already measured out how much the other side weighs by itself, so we know. So we've already started at 32 grams here. Okay. Here's our gravel first. Whew. All right. Now we're going to add some weights until they balance out. So we're going to add 20 grams. 20 grams. You know, why don't we just add 10 grams because we know that's how much the water weighs. So now we can figure out how much the gravel weighs. Got another 10. Oh, there we go. Okay. So 10 was too much. Let's try a 5. Aha. Okay, so right now we have the weight of this cup plus the gravel water mixture is, let's see, 32 plus 20 is 52, plus 20 more is 72, plus 10 is 82, plus 5 is 87. So in the weight column for our gravel mixture, we're going to put 87 grams. Okay, we want to know the total weight of everything. Okay. When I say separating a mixture, do I mean taking them both apart? Yes. We'll get to that. Let's weigh these first. All right, diatomaceous earth. Ta-da. Here's our water. Ah, here we go. So, well, not really our water because this already weighs 32. So we're already over 50 grams here. Does a 10 work? Aha. Not quite. I'm looking at the level here. The little arrow will tell me when it's right in the middle. 1 gram. Ooh, there we go. Aha. Okay. So we've got, for the diatomaceous earth's weight, we're going to have 32 plus 20, 52, plus 10, 62, plus 2. Each of these little blue chips is 1 gram. Okay, so we're going to put 64 grams for the diatomaceous earth mixture's weight. Okay, so we've got 87 for the gravel, 64 for the earth. And the last one is going to be our saltwater mixture. Okay, starting there, we're up to 52. Let's add a 10, see if that works. Okay, up to 62, add a 5. Ah, too much. Okay. Add 1. Add 1. Not quite. I think we'll get it in this next one. Add 1. Oh no, not quite. Add 1. There we go. Okay, so for the weight of the saltwater mixture, we've got 32 grams is this cup thing that holds the, whatchamacallits. 32 plus 20 is 52, plus 10 is 62, plus 1, 2, 3, 4, 62 plus 4. So we have 66 grams. Let me write all that down up here on my chart. So we had gravel, the weight is 87 grams. Diatomaceous earth was at 64 grams. Salt and water solution was at 66 grams. Okay, and then here is your visual observations. Fiona put salt water is 100% clear. Yeah. It's transparent. You can see right through it, right? Whereas that diatomaceous earth, pretty cloudy, and you can see it already kind of separate out, right? And then our gravel just kind of looks like what it is, gravel in water, right? We don't have nearly enough erosion yet to break that down, nearly enough weathering and erosion yet to break that down, okay? So filling in those as we go. On your exit ticket, which it looks like I neglected to make y'all a copy, so you'll have to make yourself a copy and then turn it in that way. Sorry, I made it harder for you, but I think you can handle it. We're going to think about our goal, and here's our focus question. How are we going to separate these mixtures? Ideally, we'd love to have a container of gravel and a container of water again. A container of diatomaceous earth and a container of water again. And a container of salt and a container of water again. How on earth are we going to separate these back out? What can we do? Okay, that's going to be up to you to try and answer on your exit ticket. I'm going to read them tonight, and then tomorrow at 12:30, we're going to try out some of your ideas. We're going to put our mixtures through whatever, filter or sifter or whatever. If you want me to pick out each grain of diatomaceous earth by hand, I probably can't, to be honest with you. But we'll give it a try and we'll see what happens. Okay, and then we weighed them, and we'll weigh them again tomorrow because I do anticipate there might be a little bit of evaporation of the water overnight. But we will weigh them tomorrow and take a look at the weight, and I'll let you know if there's any change to those weights. And then once we separate them out, we can weigh the water by itself and see if we got back down to around that 50 grams level. Sound like a plan? All right, everybody. Good luck on the exit ticket. Sorry you have to make your own copy, but I think you can handle it for one day. All right. Bye, y'all.